Here we'll derive the expression to obtain equivalent delta connected impedances from a given star. Okay. Now what we have to do is we have to consider here three impedances, that is Z1, Z2 and Z3. These are connected in star. Okay. These are connected in star. Now what you have to do is you have to obtain the equivalent delta, that is equivalent delta for this star connected impedances. So you have to find out the value for ZA, ZB and ZC in terms of Z1, Z2 and Z3. Now, as we all know that we have derived the equations for delta to star conversion. That is, we have Z1 is equal to ZA ZB divided by ZA plus ZB plus ZC. Take this as equation 1. Z2 is equal to ZB into ZC divided by ZA plus ZB plus ZC. Take this as equation number 2. And Z3 as ZA into ZC divided by ZA plus ZB plus ZC. Take this as equation number 3. These three equations are derived from the delta to star conversion. Okay. So next what you have to do is we have equation number 2, 1, 2 and 3. Now you have to multiply equation 1 by 2, 2 by 3 and 3 by 1. Okay. When you multiply equation 1 by 2, you will get it as Z1, Z2. LHS is multiplied with LHS, that is Z1 into Z2 is equal to ZA, ZB square, ZC divided by ZA plus ZB plus ZC whole square. Similarly, you have to multiply Z2 by Z3, that is equation 2 by 3 you have to multiply, you will get this. And you have to multiply equation 3 by 1. Okay, that is 3 by 1, you will get it as Z1 into Z3 is equal to this one. Now once you multiply equation 1 by 2, 2 by 3 and 3 by 1, next step is you have to add these three equations, that is 4, 5 and 6. Okay, that is the product of Z1 into Z2, Z2 into Z3, Z1 into Z3. These all three equations must be added. So what we'll do is we'll add the LHS and we'll add the RHS respectively. So here what you get is Z1 into Z2 plus Z2 into Z3 plus Z1 into Z3, that is equal to ZA ZB square ZC plus ZA ZB ZC square plus ZA square ZB ZC whole divided by the LCM remains same, that is ZA plus ZB plus ZC whole square. Now from these three terms, first term, second term, third term, in first, second, third you have ZA common, so we have taken ZA common. ZB is also common, take ZB common. ZC is also common, take ZC common. Now what remains in the first term? You have taken ZA, ZB, ZC. So one ZB remains here. Next, from this one ZC remains and from this one ZA remains. So I have arranged this in alphabetical order here, that is ZA, ZB and ZC. Next what you have to do? Here you can see in the numerator you have ZA plus ZB plus ZC and in the denominator you have ZA plus ZB plus ZC whole square. So this gets cancelled here. Fine. And what we will get, what remains here is you will get ZA, ZB, ZC whole divided by ZA plus ZB plus ZC whole square. Now if you carefully observe this, you will get it as ZA into ZB divided by ZA plus ZB plus ZC is nothing but Z1. Okay, you leave this ZC here. If you leave this ZC, this term, okay, this term will be Z1. Similarly, you will get the values for Z2, Z3 also. Now, what we'll do is, here this we have taken as equation 1. So, equation 1 is what? Z1 into Z2 plus Z2 into Z3 plus Z1 into Z3, that is equal to ZA, ZB, ZC whole divided by ZA plus ZB plus ZC. Fine. Now in place of these, that is ZA, ZB divided by ZA plus ZB plus ZC, we will replace this by Z1. Okay. So what we will get? will get, the LHS will be same, but this is, that is here, this we have replaced, okay, that is here, this we have replaced by Z1. So what will get it as Z1, what remains, ZC remains, so Z1 into ZC, okay. So what we want the value of ZC in terms of Z1, Z2, Z3. So here what we'll do, we'll transpose this at the denominator of the LHS, Z1. So ZC is equal to Z1, Z2 divided by Z1. So here Z1 gets cancelled. Then Z2, Z3 divided by Z1, it remains as it is. Z1, Z3 divided by Z1. So Z1, Z1 gets cancelled, you get Z3. Okay. So value of ZC is Z2 plus Z3 plus Z2 into Z3 divided by Z1. Similarly, you get for the other two values also, that is ZB and ZA in terms of Z1, Z2, Z3, and here the same for ZA, that is in terms of Z1, Z2 and Z3. So this is how you solve the derivation to convert the star connected impedances to the delta connected impedances. Thank you.